We're going to divide by radical, a radical divided by a radical. We're going to make the assumption all the variables are greater than or equal to 0, so we don't have to worry about absolute value bars. Part A is the square root of 54y to the 5th over, divided by, the square root of 3y. So the first step we're going to do here is put this entire fraction under a single square root. The roots match on the top and bottom. The indices are the same, so we can use a single square root and do the division under the radical sign. So here we have 54y to the 5th over 3y under the radical sign. So we can now group together the numbers over the numbers times the y's over the y's. So this is a square root of 54 thirds times y to the 5th over y. And then we can simplify. 54 thirds is 18, and y to the 5th over y is y to the top exponent 5 minus the bottom exponent 1. That's the square root of 18 times y to the 4th. Now let's factor out the perfect squares and bring them to the front and the rest to the back. 18 is 9 times 2, where 9 is the perfect square. And y to the 4th, we can write that as y squared times y squared if we'd like. And then bring all the perfect squares in the front, which just means move the 2 to the back. That's the only part that's not a perfect square. Now let's bust apart the fraction. We're going to bust it up. The square root of the first factor, 9, times the square root of y squared, times the square root of y squared, times the square root of the 2 that's going to stay locked up. Evaluate each of these square roots. We get 3 times y times the square root of 2, and then the y times y can be written as y squared. So our final answer is 3y squared times the square root of 2. For part B, we have the square root of 375 times x squared times y to the 7th, all over 10 times the square root of 3y. Bring out the 1/10. That's not under the radical. And then since we have a square root on the top and a square root on the bottom, we can write a single long, tall, big square root and put all of this fraction underneath it. It's 375x squared y 7th over 3y. Now let's bust apart or separate the number over the number times the x's times the y's over the y's to group things together. We can move things around because everything's being multiplied. And that's equal to, don't forget, the 1/10 times the square root of 375 divided by 3 is 125 times x squared times y to the 7 minus 1 is y to the 6th. Okay, now it's time to factor out perfect squares and bring them to the front under the radical sign. So we got our 1/10 times the square root of 25 times 3 times x squared times y squared times y squared times y squared. So it's 1/10 times the square root, bringing the perfect square portions out to the front. The square root of 25 times x squared times y squared times y squared times y squared times the 3 in the back, which will not be coming out of the radical. Now bust apart the pieces multiplicatively. 1/10 times the square root of 25, and each of those square roots. And you'll notice that the stuff at the very back is the stuff that's not going to get out of the radical sign. It's going to stay under there. We call it irrational, by the way, when it stays under the radical sign. Cancel the squares and the square roots. Square root of 25 is 5 times x times y times y times y times that poor square root of 3 is 5 over 10 times x times y to the 3rd power times the square root of 3. And that simplifies to 1/2 times x, y to the 3rd power times the square root of 3. And you can write it with the 1/2 separated from the rest of it. And notice that that's the same as just putting the numerator over the denominator 2.